sort of really started when graphics was quite a thing. Before graphics was your PC, our first graphics products was a card for specifically accelerating AutoCAD. In Dispatch, you had to pick out the appropriate crystal for every item shipped for whatever resolution they wanted. So that was where it started. If you think where it's come to now, in not that long a time, it's quite phenomenal. You've got to think what is going on, what the purpose of a control room is. And really, it's to bring information into that room so that the people operating in that room can make the decisions they need to make. And that can range from anything from very fine detail, text, spreadsheets, dashboards from some important thing, to big overarching control applications. SCADA is the standard for industrial control, which has every valve and every sort of thing just illustrated on a huge wall so that you can monitor the big picture. So it's fine detail. And increasingly, the operators in a control room, as well as the information that they see on the big wall, a lot of that information is brought directly to the operator workstation. A number of 4K monitors on someone's desk, that's pretty much the size of a lot of walls in terms of sort of pixel density. So you've got like a personal video wall, and then the operator is very up close and critical, and so they're even more sort of interested in the detail and the clarity of that information. It's all about that data handling, and the more data that the world throws at us, the more important that becomes. Our largest video wall now, there are something like 200 megapixels on that wall, and you refresh those 60 times a second. So it's a lot of data flying about, and you've got to be good at that. You've got to have software and hardware that understands how to be parallel so that there's not any choke points. You've got to think about where all of the bandwidth bottlenecks might be and make sure they're designed out at the right point. So yeah, it's quite a lot going on. One of the strengths of Datapath is that we are like full stack developers. Basically, we develop the hardware here, all of the actual circuit boards. On those circuit boards there's programmable logic. We've got the embedded engineers doing that. We've got engineers doing firmware on the little embedded processors on the embedded firmware, and then driver development, and then full applications. So we are able to offer quite unique products because we are in control of that entire stack. So that's how we can do the huge bandwidth things, because we've made sure that at each level it's appropriate for the job in hand. We're not just putting a sort of software icing on top of something that's quite sort of plain. We're doing the whole cake.